In this question, we are told that P, Q, and R are points on the circle, center O, and angle OPR is equals to 36 degrees. And we are required to find the size of angle PQR. So obviously, we know that if this is the radius of the circle and that's the radius of the circle, this should be an isosceles triangle, which implies that this angle here should be equal to 36. So we can easily be able to find this angle here, which will be equal to 180 minus 36 plus 36. And that will be equal to 108. So to be able to find the angle at the circumference, which is that one there, this one will be equal to, because you know that the angle at the center of the circle is usually double the angle at the circumference, then it means that the angle of the circumference will be half of the angle at the center. And that will be equal to 54 degrees. So the required angle is 54 degrees. The second part of this question, we are given this circle and we are told that Kj is the diameter. So usually what you can do is you can add a point and just add letter O to show that this is the center of the circle, so that as you walk through the problem you don't get confused. All right, so and then we are told that KGH is equal to 124 degrees. So we are required to work out the size of angle HKJ. So the first thing that you need to realize here is that this angle here, first of all, this angle here will be 90 degrees, given that KJ is the diameter of the circle. That angle has to be 90 degrees. And then to find this angle here, we know that opposite angles in a cyclic quadrilateral add up to 180. So opposite angles in a cyclic quadrilateral add up to 180. So it implies that this angle here will be equal to 180 minus 124. And that will be equal to 56 degrees. So this angle here will be 56 degrees. Now, if that angle is 56, we can easily be able to find the required angle here, because angles in a triangle add up to 180. So this angle here will be equal to 180 minus 90 plus 56. And if you work out that, you'll end up with 34 degrees. So number 13, we are given this circle, and the first question is to find the size of PQS. So PQS is this angle here, and obviously we know that angles extending to the circumference from the same arc are equal. So angles extending to the circumference from same arc are equal. So angles extending to the circumference from the same arc are equal, which means this angle will be 41 and therefore 41 degrees. All right, so in the second part of this question, we are required to find angle PTS. Now, obviously, if you look carefully here, we can see that QTP, so QTP, this angle here, will be equal to, so QTP will be equal to 180 minus 41 plus 34. And that will be equal to 105 degrees. So this angle is 105. And if that's 105, we can easily find angle PTS. So PTS is this angle here. So PTS will be equal to, just because these are angles on a straight line, so 180 minus 105, which will be equal to 75 degrees. So this will be 75 degrees. And then explain why T cannot be the center of the circle. Now just remember that if T was the center of the circle, then this will be equal to that. Yeah? If it was the center of the circle, then those two, so if T was the center of the circle, then QT would have been equal to PT, which implies that angle PQT would have been equal to angle QPT, which implies that angle PQT would have been equal to QPT. But of course, if we look from our calculation, you can clearly see that PQT, yeah, which is 41 degrees, is not equal to QPT, which is 34 degrees. And therefore, T is not the center of the circle. So the reasoning for this is here. Yeah, the reasoning for this is there. So basically what we can do here is we can say, well, T cannot be the center of the circle because PQT is not equal to QPT. And that's it. That explains why that T cannot be the center of the circle. Number 14, we are told that JKL are points on the circumference of the circle. GJH is a tangent to the circle at J, and MK and JL intersect at point P, and GML is a straight line. And we're given all this information. So the question here is, write down the size of angle MLJ. So MLJ is this angle here. Of course, this angle will be equal to that. So this will be equal to 21 degrees. So 21 degrees. And this is because we know that angles extending to the circumference from the same arc are equal. So part B, write down the size of angle JLK. So JLK is this angle here. Now this angle here will be 62 by alternate segment theorem, because this angle and that angle will be equal. Yeah, so let me draw this properly. So this angle and this angle here will be equal. So by alternate segment theorem, JLK will be equal to 62 degrees. All right, so and then we can carry on to find the next part of this question. Work out the size of angle KPL. Now, to find KPL, let's consider this triangle here. So let's consider this triangle here. So consider the highlighted triangle. So if you consider the highlighted triangle, I want to use that highlighted triangle to find angle GJL, to find this angle here. Yeah. So GJL will be given by angles in a triangle add up to 180. So to find this angle here, we'll just do 180 minus 21 plus 78. And the resulting answer here will be 81 degrees. So this angle will be 81 degrees. And then what we can do again here, because remember what we want is KPL, KPL. So we want this angle here, KPL, we want this angle here. So what we can do here is to try and work out this angle. I'll try and work out this angle here. Angle LJK. So LJK, because these are angles on a straight line, 81 and 62 and LJK. So LJK will be equal to 180 minus 81. All right. Hold on. So this will be equal to 180 minus 81 plus 62, which will be equal to 37. So this angle here will be 37. And then I'll carry on to find the value of this angle here, which is JPK. So JPK will be equal to 180 minus, we know that angles in a triangle add up to 180, so that's 7 plus 21, and that will be equal to 122 degrees. And therefore, because these two are on a straight line, this is 122, the other one will be, which is given by KPL, so KPL will be 180 minus 122 degrees. And KPL will be equal to 58.